Hello, AP Calculus. Here we go. Here are the notes that we did on August 20th, Tuesday, in class. So you can take better notes if you weren't following along in class. So this first part, we've got this limit here. We've talked about it. When we factor the bottom and the top, we would get x plus 3, x plus 1. Add x plus 3, x minus 1. And so we've got two different things going on here. At -3, we've got something happening, and at 1, we have something happening. Notice that those are the two places where something's happening in this rational function. So if you look here is a graph of this equation here. And so we're trying to find the limit, like I said, at the two different places where something special is happening in our denominator. So you may not remember, but a lot of times last year in pre-calculus, we talked about finding what is the domain, because there are places in our domain where special things happen. And for rational functions, we often found either a hole or we found an asymptote. And so if we have a hole, we're able to find the limit because there's a left-hand limit, it's getting close to this number. There's a right-hand limit, it's also getting close to that number, so we have an overall limit here at -3. But when we look at 1, we've got that asymptote, we've got an infinite discontinuity, so there's not an overall limit. But we can find a left-hand limit or a right-hand limit. So it says, from the graph of the function below, picture to the right, what is the value of each limit? And they're nice, they gave us the coordinates of the whole. So the limit of this guy, y is getting close to, I think that's supposed to, oh yeah, here's your x-axis, I'm thinking this is x-axis. Here's the x-axis, y is getting close to 1/2 on both sides, so the limit, the overall limit would be 1/2. My left-hand limit of this guy, at 1, as we approach 1 from the left-hand side, we're going down to -infinity. And my right-hand limit, as we get close to 1, it's popping up to +infinity. So we can tell if we're given the graph, it's real easy to tell this is what's going on. Well, not real easy, but we learned it last week, so we remember what's going on there. But if we didn't have the graph in front of us and we're on an AP calculus exam, and it's the non-calculator portion, we might struggle with this. So we have to learn some algebraic techniques for finding limits when we don't have calculators. And so this is the first one. And anytime you see like this polynomial over a polynomial, it should be, and when you plug in 1, so like when I plug in 1 here, I've got 1 plus 2 times 1, which is 2 minus 3. That gives me 3 minus 3. I get 0 in the denominator, so I couldn't just straight away plug and chug on these. The first thing I'm going to try is looking and seeing if I can factor it. So that's going to be the first step that we're going to do for these problems. Step 1 is factor both the numerator and the denominator. And we're doing that to see if we can find a factor that will cancel. So 2, if a factor cancels, then we have a whole. And like we just talked about up here in this picture, a limit can exist. Or at least we can check to see if it exists, and we can find the limit. And we find that limit by evaluating the function, the resultant fraction or function. And we're going to do a couple of problems. I love how it's changing from red to black, and that's sweet. All right, so we're going to talk about, we're going to do a couple of examples so you'll see what we're talking about for that one. In fact, let's just go ahead and do that. So let's do our first example here. Here's that same fraction that we saw above. At -3, we saw there was a hole, so we at least know what we're supposed to be seeing. So we're going to find the limit. Let's go ahead and factor out our numerator and our denominator. Our numerator we said is x plus 3, x plus 1. I'm so happy that you guys are really good at factoring at this point. X plus 3, x minus 1, except for that cubic. You struggled with that one today. All right, so we factored it out, and we have a factor that cancels, and that happens to be where we're looking at, which is great. So if it cancels out, we know that we have a hole. From this, we know there's a hole at x equals 3. Negative 3, sorry, negative 3. Make that more clear. There's a hole at negative 3, and we can find the limit of that hole, or the function as it approaches the hole, by plugging in negative 3 into, this is what I'm saying when I say the resultant function or the resultant fraction. So negative 3 plus 1, negative 3 minus 1, that's negative 2 over negative 4, which becomes positive 1/2. And as we saw in the graph, and they told us nicely, the hole here is at negative 3 1/2. So that's what we do when we have holes. This is the first video for today. I'm actually going to stop this video here. It's kind of short. The next video, I'm going to show you some examples of this one. And then I'm going to give you a video for when we have an asymptote. And then the last video will be examples of the vertical asymptote.